Welcome to The Explainer. Today, we're going to talk about something that's basically the secret sauce behind how giants like Netflix and Uber can handle just massive, massive scale. It's called event-driven architecture. So let's jump in and figure out what it is, and more importantly, why you should care. You know, our whole digital world runs on these incredibly complex systems. But here's the problem. As you keep adding new features and more users pile on, those systems can get super fragile. So the big question for everyone building software today is, how do you design them so they can grow, but also so they don't completely shatter under pressure? Well, a big part of the problem is in how systems have traditionally been built. Everything is connected directly to everything else. Think of it like a house of cards. Each service is tightly coupled. And if just one card wobbles, say your payment service has a hiccup, it can trigger a chain reaction that brings the whole thing crashing down. That's a cascading failure. And trust me, it is an absolute nightmare for any engineering team. Okay, so to avoid that total collapse, we really need a different way of doing things. And that brings us right to our main topic, event-driven architecture, or EDA for short. And it's really less about a specific technology and more of a whole new way to think about how all the pieces of a system talk to each other. So what is it really? An event-driven architecture is all about building systems where the different parts are loosely coupled. Instead of services calling each other directly and waiting for a response, they communicate by just shouting out that something happened. That something is an event. And an event can be anything, really. An order was placed, a user updated their profile, a new item is in stock. It's just a little notification about a change. Let's break that down into 3 simple steps. First, you've got an event producer. Let's say it's your ordering service. When you place an order, it just generates an event, like a little message that says, hey, an order was placed. Second, that message gets sent to an event channel. You can think of this like a super reliable post office, sometimes called a message broker. And finally, you have one or more event consumers just listening to that channel. When they hear an event they care about, they pick it up and do their job. The beauty of it is the producer has no idea who's listening. It just sends the message and moves on. That's the magic. Now, before we get too carried away, we have to talk about the big trade-off here. When you build an event-driven system, you're building a distributed system. You're moving from a simple, predictable monolith to something that's spread out with lots of moving parts. And let me tell you, distributed systems are hard. They come with a whole new class of problems and complexities that you just don't have to worry about otherwise. So, if they're so much harder, why on earth would anyone bother? Well, because the payoff is absolutely huge. The benefits of that loose coupling we keep talking about aren't just theoretical. Let's look at the actual data, because this is where it gets really compelling. This table, based on some research from the International Journal on Science and Technology, really lays it all out. Look at this. Event-driven systems can slash the dependencies between different teams by 60%. That means teams can work more independently and move faster, and system availability is way higher. But the number that just jumps off the page is the system throughput. Yeah, this chart really says it all. During peak times, we're talking Black Friday, a big product launch, you name it, an event-driven system can handle 3 to 5 times more traffic than a traditional one. That is the difference between having very happy customers and having your website completely crash and burn. So, here's the key takeaway. That incredible performance and reliability all comes from loose coupling. Because services aren't directly waiting on each other, they can act on their own. If the service that sends shipping notifications goes down for an hour, who cares? Customers can still place orders. The order-placed event just sits patiently in the event channel, waiting for the notification service to come back online. That whole cascading failure we talked about, it gets stopped in its tracks. Okay, so the tech sounds amazing, right? But all these powerful tools don't solve what is often the single hardest part of doing this right. And it's not really a technical challenge, it's a design challenge. This right here is the question that trips up so many teams. It's one thing to say, let's use events, but it's another to figure out what an event even is in your business. Which service is in charge of creating an order-placed event versus an order-shipped event? How do you carve up your big, complicated business into these smaller, independent pieces that can talk to each other cleanly? This quote from Brian Zambrano, an architect at AWS, just nails the problem. You can go read a blog post to figure out which message broker to use. That's a technical problem. But finding your business's domain boundaries, figuring out where the natural seams in your system are, that's a unique challenge for every single company, and you can't just look up the answer. So how do you find those boundaries? Well, the answer often comes from a discipline called domain-driven design, or DDD. And the most important thing to get about DDD is that it is not about writing code. It's a toolbox of ideas and practices to help everybody, the engineers, the product managers, the business experts, get on the same page and develop a shared understanding of the actual problem they're trying to solve. This quote from Alberto Brandolini really gets to the core of why this is so critical. Think about it. Most big software disasters don't happen because engineers are bad at programming. They happen because the engineers, through no fault of their own, didn't fully understand what the business needed them to build. It all comes down to miscommunication. To close that communication gap, there's a really cool technique called event storming. It's basically a workshop. You get everyone who knows anything about the business process into one room with a huge wall and a ton of colorful sticky notes. And together, you map out the entire process by identifying all the events that happen along the way. It makes the whole system visible to everyone, and you literally see the boundaries emerge on the wall. It's a blueprint you create together. All right, so you've found your boundaries, you're ready to build. Now we have to talk about messy reality, because the real world is chaotic and things will go wrong. So let's talk about how to design systems that are ready for that chaos right from the start. First, let's clear up something that trips a lot of people up. Event-driven architecture is not the same as event sourcing. Think of it this way. EDA is a communication pattern. It's the postal service, all about how different services send messages to each other. Event sourcing, on the other hand, is a data storage pattern. It's like keeping a perfect, unchangeable diary of every single thing that has ever happened. They work great together, but they solve different problems. Now, if you're building for resilience, you've got to avoid some common traps. A huge one is designing your system for an average Tuesday afternoon instead of for that sudden, massive, unpredictable spike in traffic. Another is thinking that just retrying a failed operation will fix everything. Sometimes retrying over and over just makes the problem worse. And finally, you have to realize that not all events are equally important. Processing a password reset is probably more critical than updating a recommendation. So, to fight back against that chaos, we can use some proven, battle-tested patterns. Queues and buffers act like shock absorbers to smooth out those traffic spikes. Cool techniques like shuffle sharding help contain the blast radius of a failure, so a problem for one small group of users doesn't bring down the whole system. And the fail-fast principle is all about signaling problems immediately, instead of letting things hang and time out, which can cause, you guessed it, a cascading failure. Using all these patterns means you have to get comfortable with a core idea in distributed systems, eventual consistency. And it sounds scarier than it is. It just means that when data changes in one place, it might take a tiny bit of time for that change to show up everywhere else. Think about it. When you update your profile picture on social media, does every single one of your friends see it in the exact same millisecond? No, of course not. And that tiny delay is exactly what allows the system to be so resilient and handles so much scale. So as we start to wrap this up, it becomes really clear that adapting an event-driven architecture is about way more than just new technology. It's a fundamental shift in how we even think about building software in the first place. I absolutely love this quote from Rajesh Kumar Pandey because it just flips the whole script. Resilience isn't about avoiding failure, it's about embracing it. The goal isn't to build a system that never ever fails, because that's impossible. The goal is to build a system that expects to fail and is designed to handle those failures gracefully without falling apart. So I'll leave you with this question to chew on. How could embracing failure, accepting a little bit of chaos, and getting comfortable with eventual consistency change the way you approach building your next system? Thanks for tuning in to The Explainer.